I'm Dr. Donald McEachran, a teaching professor at the School of Biomedical Engineering, Science, and Health Systems. And I'm here to see if you know the answers to a few questions. For example, why do students often feel better in the morning after they've been studying all night compared to when they were in the middle of that night? Why do traffic accidents increase after the change to Eastern Daylight Time year after year after year? Why do some drugs vary in their effects by as much as 1,700% at different times of day? Why do I wake up before the alarm when I'm on co-op, but not when I'm back on campus? Why do some people enter into a depression every fall only to spontaneously recover the following spring? Why do I feel so tired after traveling across multiple time zones? And why do asthma attacks cluster at 4 in the morning? Why are all these things and many, many, many others involving time observed in biological systems? Well, as it turns out, Chronos knows. Chronos is the Greek god of time, and he knows that it's all about time. Time and the biological rhythms that are critical and essential components of all living systems. The timing of neurons, neural oscillations appear to underlie communication within the brain, sensory perception, cognition, memory, and every other activity in which the nervous system engages. Metabolic cycles, like this glycolytic cycle in yeast, are found throughout organisms, including human beings. Pulsatile endocrine rhythms, like this rhythm in gonadotropin releasing hormone in a female sheep or ewe. Interestingly enough, given as a pulsatile rhythm, gonadotropin releasing hormone generates reproductive cycles in the female. If given as a constant infusion at a constant level, it not only does not generate reproductive cycles, it acts as a contraceptive. Rhythmically, you get reproductive cycles. Constantly, you get the rhythm, the reproductive cycle to shut down. And then there are daily rhythms, rhythms in virtually every physiological, biochemical, and behavioral parameter of all eukaryotic organisms seems to vary on a daily basis. Here you can see the daily rhythm in pineal melatonin, both in young men and women and in older individuals. And this decrease in amplitude and change in phase has implications for the aging process. There are daily rhythms in gene expression in almost every gene in the genome. There are annual rhythms in reproduction, in seed germination, in flowering, in whether or not plants will retain their leaves, in fur color. And in human beings, there are annual rhythms in birth. And finally, rhythms cascade all the way up into ecosystems, as you can see from this diagram of population changes with lynx and hare, all about time, all about biological rhythms. Why all these rhythms? And how do we understand and use them to improve healthcare and the quality of life? Well, that is what we will try and find out in the 2 courses in the summer dedicated to chronobioengineering, BMES 411, and the graduate version, BMES 531. I hope to see you there.